So can everybody hear me? Oh, I guess so. Sounds pretty loud. So you guys in the back can hear me all right? So I got a couple more minutes left to before I begin, but it's pretty good to see some people here. It's the last slot, so I'm kind of surprised there's actually anybody still awake and hanging in there. I know last year this time I was basically a zombie, but I was doing booth duty last year, and so like you'd think that handing out T-shirts and USB drives would not be that tiring, but you try doing it for 6 hours straight, and it's pretty exhausting. So this year no booth duty, so I'm actually pretty awake now. Can actually present on a session. So wait a couple more minutes and let see if there's any more stragglers coming in, but then we'll get started. All right, so it's 4:30 by my clock, so I guess looks at one more straggler coming in. So all right, so this will get started with my session here. So my session is getting to know Linux I/O, building a quick and easy iSCSI SAN on Linux, and I'm Kirk Kosinski. And so in that title there, it sounds kind of, you might be skeptical, quick, easy, iSCSI SAN Linux. These things don't really go together, but believe me, actually, it might actually be possible, especially after you watch this session. So first, we have the agenda. Basically, just tell you some background information, and then get into the actual, the Linux I/O part of it. So about me, well, basically, I work for Citrix Systems, and previously I was at Cloud.com until it was acquired by Citrix Systems, and I'm an escalation engineer there, basically providing support to the customers. And the product I'm supporting is basically Apache Cloud Stack, the Citrix version of Apache Cloud Stack, which is Citrix Cloud Platform. And so basically I've been involved with the Cloud Stack for a while. I'm a committer on the project, so I deal a lot with Cloud Stack. If you're familiar with it. If you're not familiar with it, it's kind of like OpenStack, but just a lot better. But anyway, there's my contact info, Twitter and blog and stuff. And I also have some certifications, Citrix certifications of course, and some VMware and Microsoft, kind of just focused on virtualization in general, and also just some general systems admin type stuff. And previously, before this current role, I was doing systems administration for a few years for a university and for some nonprofits. So you may be wondering why you should care about shared storage as a systems administrator. Well, there's a lot of common uses like clustering, virtualization, but if you're a systems admin at a lot of organizations, you might not be allowed to touch the shared storage. You would just have a storage administrator that you would call, and then he'd get back to you in a week with creating your LUN or whatever. But even if you're not controlling it at work, you still might have to know a little bit about it. Like if you're configuring any kind of virtualization product or any kind of clustering product, you're definitely going to have to use some kind of shared storage. Now, and of course, even if you have a storage administrator at work, you might not have a storage administrator. Also, like if you're in a smaller organization, you might be the storage administrator, even if it's not in your job description. So you might have to set it up yourself. And even if you don't have to do it at work, you still have to learn about stuff. So often learning about clustering or any of the common use cases that require shared storage, you'll still have to deal with it on your own or in some kind of lab environment. So hopefully this talk will be useful to most of you. So just give you some basics about shared storage. There's two basic types. There's file-based and block-based. And so file-based you can think of like as shares, like file shares, like a NFS share or a CIFS or SMB Samba share type thing. And basically the clients of the shared storage, they're accessing actual files. The shared storage is sending out the files to the clients. And block-based is basically just raw data. So you would, instead of having shares, you would have things called LUNs. And two common types of block-based shared storage is Fiber Channel and iSCSI. And then kind of in general, you would have like file-based shared storage would be called like a NAS, and block-based would be like SAN. But that's nowadays the solutions that's marketed as a NAS or a SAN, they probably provide both. But yeah, historically that's kind of how it was. But as far as the talk goes, I'm going to focus on iSCSI just for some reasons I'll go into shortly. So iSCSI, really one of the main things about iSCSI is that it can be purely software-based. Basically, you don't have to buy any specialized hardware. With Fiber Channel, you're going to have to buy, a SAN that has Fiber Channel interfaces, and you're going to have to buy the Fiber Channel cables and a Fiber Channel switch, and then more cables to connect to your servers that need Fiber Channel adapters. And if you're buying this, new from some kind of vendor, you're spending thousands of dollars just to get the hardware. With iSCSI, it can all be done in software. You can just be using just your regular network, your regular Ethernet NICs and everything. It's just nothing special. You could just have it all in software, like in VMs on your laptop or a desktop at home or something. So it's really easy to get started with iSCSI. That's not to say it's only software based. You can certainly buy hardware iSCSI stuff like adapters to do things more high performance or something if you have some need for that. But then the software based stuff of iSCSI has come a long way. It's actually pretty good, pretty high performance and flexible, and really, and certainly for learning iSCSI and setting up SANs and stuff, it's really good, really easy to use. So in iSCSI, it's following like a client-server model, where the client would be called the initiator and the server is called the target. So don't get those confused. And once you know those two terms, it's pretty easy to get to understand what people are talking about when they're talking about the iSCSI initiator versus target. So the target's the server and client's initiator. The standard port for iSCSI is 3260 TCP. So some other iSCSI basics, basically the nodes in iSCSI they basically have names called IQNs. And this is the format. It's like IQN and then some kind of date, or like a year and a month, and then a domain name reversed, and then a colon, and then some kind of identifier. It doesn't have to be there. I mean, this is all kind of arbitrary. You can name it whatever you want, but this is kind of like the standard format. So here we have just one I made up, and then another one that would probably be something you could see on like a Red Hat machine if you're using like default settings. So in iSCSI, I mentioned you have these things called LUNs. This is kind of a term from SCSI. It's logical unit number. Basically, it's a disk. You can think of it as a disk that's being made accessible through this iSCSI on a target, basically. And then ISNS is kind of just like a centralized management protocol to kind of like aggregate and make things, basically the LUNs easier to find, for example. So like if you're on your initiator, you didn't know exactly, you might have a lot of different iSCSI targets available, and then you could kind of just aggregate them all through this ISNS protocol, so that like when you're configuring the initiator, you just point to this the ISNS server basically, and then it would know all the LUNs that are available. So if you're doing iSCSI for learning or lab purposes, you might be tempted to go with some kind of like turnkey solution. And here's a few of them: OpenFiler, FreeNAS. There's a lot of them. These are just some of the more common ones that I've heard of. And these are a good option, actually. I think for a lot of people, if you're just learning, getting started, it's totally fine to get using these for setting up an iSCSI SAN, because it can be complicated, and certainly for just learning. You might not want to get too deep into learning about the protocols and all this iSCSI stuff. But so some details about these solutions. The first three, basically, they're actually like a whole turnkey solution. They're actually like an operating system. You just can download like an ISO and install it on a server and configure your SAN. Basically, it'll turn your server into like a SAN essentially. And the last one is StarWind. It's actually installed on Windows, so you'd have to install Windows first and then install this StarWind iSCSI target. And so these have some, a lot of pros and cons. Like pro, obviously, is very easy. One of the cons with StarWind, you need Windows, so that's a big negative on there. You have to deal with some kind of licensing there. But there's some other cons I've run into. I mean, I've used these kind of solutions in the past and did run into some kind of issues. One of the things is that for one thing, there might be limitations in the GUI. Basically these are made to have a GUI to make things easy, but there might be some limitations there. There might be something that you want to do that you would, if you're familiar with iSCSI and how things work, then you might want to do this thing in a certain way, but the GUI just won't let you. And then if you go ahead and you think, well, maybe I'll just go and log on to the as root on the OS and do it myself. Well, then it kind of can conflict with the GUI and mess things up. And besides those kind of limitations, there also might be limitations like basically put in on purpose. These four examples. There's other examples too, but these four examples. They're all sponsored, basically. They all have organizations behind them that are trying to sell you something as well. So you might download these, the community edition or the free version or whatever they call it, and then hit some kind of limitation that requires paying to upgrade to the paid supported version. So And then another thing about these in general is that you might not be that familiar with the underlying operating system. Like me, I'm not that knowledgeable on FreeBSD, so if I install FreeNAS and it hides everything from me, and I can do everything in the GUI, but then if there's some kind of problem, I have to log in as root and do something, then I would, I'm really familiar with Linux, so I can probably poke around and do some things in FreeBSD, but again, then you might, if I really cared about that box, then I might be tempted to pay for the supported version. So there's some pros and cons, and you can look into it. Besides those type of solutions, there's actually solutions that's actually built into common operating systems. So actually all those turnkey solutions, all they're basically doing is just building on top of what's already available in the OS, more or less. So these common operating systems, the only one I can think of that, as far as I know, can't do iSCSI out of the box would be OS 10, but maybe you can certainly buy something to set up iSCSI target on OS 10, but maybe not out of the box as far as I know. But basically, in the common operating systems listed here, they all have iSCSI capabilities built in, just either in the OS as you install it, or in some kind of official packages that are in the official repositories for this for the OS, right? So with Linux, actually there's several, but Linux IO would be one of them. Obviously, the one I'm talking about for this presentation, and then so with the OS, when you're doing this kind of setting up iSCSI, you can use whatever is there, like Linux IO, for setting up the iSCSI target, but then also you can basically use, as far as the disks that you want to use, you can just use whatever the OS supports, which is going to be a lot of different configurations, pretty much whatever you want. So with Linux IO and Linux for setting up iSCSI target, basically you could use any kind of storage that Linux supports. So you could set up, like, if you wanted to buy like a hardware RAID adapter that's supported by Linux, then you can do that. You could just buy LSI logic card and set up your disks and whatever, and use that. Or you can just use any block device, or you could use like software RAID with MD. It's really pretty flexible. And besides Linux, of course, you can use BSD. Like there's in BSD, I think the iSCSI target is called ISTGT, and then you can, again, kind of the same thing as with Linux. You can use whatever kind of disks that's supported with BSD. So one of the kind of cool ones with Linux is ZFS. So you might want to use OpenZFS with like FreeBSD or something, and that'll be a perfectly fine solution. As far as I know, this is actually what FreeNAS is using. They're using ISTGT and OpenZFS. And then they put their really slick GUI and everything on top of that, and you don't have to worry about the underlying stuff. And now with Solaris and Solaris derivatives, like what used to be Open Solaris, and then now there's Open Indiana, they have an iSCSI target called ComStar, and then you can use ZFS with that, and it's really feature-rich and everything. It's great. And then with Windows, there's even an iSCSI target with Windows if you like to use Windows. With Windows Server 2008 R2, it's an optional download. It's free from Microsoft. There used to be a dedicated Windows Server version, like Windows Storage Server, that you'd have to buy if you wanted to use Windows as an iSCSI target. But then, I don't know, probably nobody's buying it, so they just made the iSCSI target free. So, and in Server 2012, it's actually now built into the OS, and it's just a server role. So if you're familiar with Windows, you can just go into the Server Manager and click a box and click OK and everything, and then you'll have your iSCSI target installed. And so, what about why do I like these? Well, one of the reasons is I kind of like to just learn about what's happening under the hood, and so it's nice to know that the actual underlying technology a little bit better than you would get with some kind of turnkey solution that's basically abstracting a lot of the technical stuff. But besides that, you can use any distribution you want. If you want to use Linux, and this is the Linux Expo, so probably you guys want to use Linux, well, you can use whatever distribution you want. You can use Fedora or CentOS or Ubuntu, Arch. Basically, most of the general purpose Linux distributions are going to support Linux IO, and certainly going to support the disks, any kind of disk configuration you want. So it's really nice to be able to use what you're familiar with. If you're a Ubuntu guy, then you can use that, or you can use Fedora if you like Fedora. It's pretty nice. And then also another reason is, I'm using Linux for a long time, so I'm pretty familiar with the command line of Linux, so having a GUI is not actually that much of an advantage for me. If I actually can, check a man page and figure things out, then, why do I need to bother with going through some web interface and clicking, figuring out where to click here and there and doing it. Having command line is pretty nice. And I found with Linux IO, it's actually pretty, like the command line is really nice, actually. It's pretty good, and I'll show you a little bit, I'll show you in a little short time about that. And then, besides that, like why you want to use that, another reason would be just so you can use Linux in general, right? Like, with Solaris, I've used Solaris. I used Open Solaris before for SAN, and that was the only open Solaris box that I used, and so it worked fine and everything, but I was always kind of nervous that it would break, and then I wouldn't, I'm not a Solaris expert, so, and I can poke around with Bash or whatever and try to figure things out, but, it always made me a little bit nervous about using Solaris. So, it's nice to be able to use Linux and have really good features and good performance, and just being in an environment that I'm just quite familiar with. All right. So just some history on Linux iSCSI. There's actually a lot of ways to set up iSCSI targets on Linux. Here's four examples. If you've done it before, if you've done it a few years ago, you might have used IET, which is iSCSI Enterprise Target. I think this, as far as I know, this was kind of the standard, 5 years ago. Basically, if you did iSCSI on Linux server, then you're probably using this IET target. And it seems like it kind of fell out of favor. Just a few years ago, there was just some bugs, and like it didn't work very well with vSphere, for example, for a while. And then that's I think that kind of prompted some other projects to come out and start trying to compete and replace iSCSI Enterprise Target. And so actually, I think at this point, they're all kind of maintained. So you can actually still use IET or any of the other ones. The STGT, I checked the website, looks kind of out of date, but the packages are still in like Fedora repositories, I checked, so you can still use that. And there's the URLs if you want to research it. And it actually seemed like there was a lot of competition there. I was like reading some of the mailing lists, and there's some people that seem like mad mad at each other. So there's seems like there's some politics there. So I don't want to go into that. So if you want to learn about some of these other targets, you can just go check the URLs. So I'm gonna just focus on Linux IO, which is the last one. There's the URL. So preparing for Linux IO is actually really, I don't know, for me it couldn't be easier. It's just extremely simple. Step one, you install Linux on your host that you want to use as your SAN, basically. And so which Linux? Well, you just use whatever one you want to use, basically. As long as it's, a more general purpose Linux distribution, then it's probably just going to support Linux IO out of the box. If you want to use Mint or something that's really specialized on something like desktops, for example, with Mint, it might not be there. I'm not sure. It might even be there with Mint. I'm not sure, but certainly with any of these listed here and many other ones, it's going to be supported out of the box. One exception I found was Gentoo didn't seem to support it because some of the tools were masked, so in other words, unstable, and it seems like you'd have to unmask them and do a little bit of extra work to get it to work, but probably still would actually work, even on Gentoo, especially because basically, well, my next slide will go into a little bit more detail on this. And so next step, preparing for Linux IO, after you install Linux, you need to configure the disks. Maybe you did that before installing Linux. If you're doing hardware RAID, then you'd probably do that before. If you're doing software RAID, then after installing Linux, you could just configure your software RAID array or something, or you can use any block device will be fine as well, so LVM or basically just whatever you really want to use, then you can use that with Linux IO. So the last step would be configuring the network and firewall for the host. With iSCSI SANs, there's really any number of ways to configure the networking. You might just have, if you just have a basic lab, your server might just have one NIC just doing everything. That will be fine, that will work. Performance might not be good, and security, will be concerned, but you could do it like that. But more common, you'd probably have some dedicated NICs for a storage, so-called storage network that would be used just for storage traffic. Probably wouldn't be routed; it would just be purely used for that iSCSI traffic. And you might even have multiple networks for this. But it's really up to you. Once you've kind of decided on the actual physical network topology, then you would go ahead and then configure the firewall in the OS. So configure like IP tables basically, and it depends on security policies or preferences. You could just open the ports, or just allow all traffic from the initiators or the clients, or just make the interface just allow all traffic. It's really up to your preference. So now, as far as installing Linux I/O goes, it's just super easy. It's the kernel contains the subsystem. There's just some modules that's included in the kernel. As long as you're using a pretty general purpose distribution, then it should have this option enabled and have these modules installed by default. So looks okay, you can see. So yeah, it's really, if you happen to install and then you don't see these modules, then it might be not compiled as a module. So just check for the option in the config, and might still be there. So besides the kernel, and of course, if you really want to, if it's not there with the kernel shipped by whatever distribution you want, you could just go ahead and enable it and recompile kernel yourself. And with Gen 2, you're doing this anyway. And some other many situations, you might need to compile the kernel yourself anyway. So then you could just enable the option to get the modules you need. So besides the kernel modules, there's basically libraries and a UI, and really it's just a handful of packages. And so like the libraries for Linux I/O is called rtslib, and there's a package name, that's the package name for Fedora and Ubuntu. Then on the UI, there's this UI called target CLI. It's just a command line user interface, basically. And there's a package name, target CLI, pretty straightforward. And so actually here's a screenshot. Hopefully, yeah, it looks okay. I guess can everybody see okay? Yeah, okay, good. So basically on Fedora is super easy to install. You don't even really, all you need to know is target CLI. Just yum install target CLI. It'll install all the dependencies, including all the libraries you need to use Linux I/O. So it's like literally like one command after installing Fedora to get Linux I/O installed. So just, so far it seems pretty easy. So now, of course, installing things is pretty much the easiest part usually. So the hard part would be configuring. But actually with Linux I/O, it's actually not that bad. So with these are kind of like at a high level, there's two basic components of Linux I/O configuration. There's this service. Usually it should be called target. That's what it's called in Fedora. I don't know about Ubuntu, but it's probably called target in Ubuntu. And this it's not actually a daemon or anything. It's just I think it's just like a script basically that runs at boot time and applies the configuration and then exits. It's not something that's going to be running at all times at all. It's just going to just run and apply the configuration. So actually it makes things a little bit interesting when you're looking at what's happening, because there's no daemon handling this iSCSI traffic. Basically, it's all in the kernel. So like if you're actually looking for like a process that's listening on this iSCSI port, there's no process. It's just the kernel's listening on it. So it's kind of interesting. And then so besides the service, there's this target CLI I had mentioned. That's what you use to create the configuration. And it's really cool. I really like it. It has basically two modes. Has like an interactive, well, has a non-interactive mode where you can just type target CLI space command at a bash prompt and then press enter, and it'll run that one command and then exit. But the really cool thing is that it has interactive mode, and this interactive mode just makes it really simple to do the configuration. This utility follows some like standard Unix conventions. So basically, like the configuration actually looks like a directory structure. So like commands like ls and cd, you can like navigate around the configuration and make the necessary changes in the necessary part of the configuration, really quickly and easy. And it supports tab completion. It's really a handy thing. And here's just like a screenshot of just like a basic usage of this target CLI. So the first line, I'm just kind of demoing the the non-interactive mode. So I'm just running target CLI space ls, and then it's just listing out basically like a summary of the configuration. And at this point, there's no configuration, but so like everything is basically at the default. But then you can also just type target CLI and then enter, and then you'd get into this interactive mode. And so you can see the same ls command in this target CLI prompt is doing this, showing the configuration, basically doing showing the same kind of thing in a different way. So as far as configuring Linux IO, the details, well, here's basically an overview. There's basically like 6 steps to configure a basic SAN, and that's it. It's really, that's it, 6 steps. And then, step 7 is just saving it. And then step 8 is configuring the initiators, which is the clients, right? So, so I'm just going to go through these steps now. So first step would be configuring the backstores, what's called backstores. That's basically some kind of storage that you want to use for this iSCSI target. That's going to be, the iSCSI target's going to make this storage available to the initiators, to the clients, right? So, and this is actually really easy, because if you've already, followed the previous slides and prepared for Linux IO, you already have the disk configured, right? So in this example, you can see in the target CLI prompt, and then I just change to the backstores / block area of the config, and then just type in the command, create, and then a name of this backing store. I just call it BS0, and then the block device, which is dev-vdb. That's it, and now that's added. And then when I use ls command, it will show the configuration. I used it at the basically twice. It will show like at the block level or the backstore level, and it will show, okay, well under block devices, I have this one BS0 backing store, or backstore, and have the details there. And then I use CD back to basically like the root of the configuration, and then list out the whole configuration. So you can see basically it looks the same as the previous example, except that now we have a block device listed there. So next step would be creating the target. And again, it's more of the same. You're creating you want to create an iSCSI target, so you navigate to the iSCSI section of the configuration. Just do cd space iSCSI, and then type create, and it created this target for me. If you don't want to use the default IQN syntax, you can just type create space and then type out the IQN yourself. I didn't want to do that, so I just let it create the IQN for me, basically. And then navigate back and show the configuration again, just to show that, well, now we have this basically this iSCSI target created. And then this other thing in this utility did was creating the portal group, and by default. So on the next slide I'll explain that a little bit. So the next step I had mentioned earlier, in the steps of 6 steps, one of the steps is creating a portal group. Well, I actually created a portal group by default for me, and if you want to use the default one, you can do that. So you can see, like on here, it created this portal. So what's a portal group? Well, a portal group is a group of portals. And so what's a portal? A portal is basically an IP address and a port that you want. Yeah, do you have a question?
Yeah, if you're going to get to this later, no problem. But
yeah.
On the IQN names, what is the convention about what the date is? It's not today's date, obviously.
Right, yeah, the date, I think the convention is just when the organization was like created or something. So like with the Red Hat one, it's like 1994 or something like that. So
it's not going to change.
Yeah, it's not going to change. That's like a fixed value. And I mean, it's just totally arbitrary. You can just use whatever you want. If your company is founded in January of this year, then you can put 2015-01. It's really up to you. There's not like any technical reason there. And I think there's probably an RFC you can read if you really want to get in there and be like super stickler to the rules. And or you can just ignore all that and just name the IQN whatever you want. You don't have to use the syntax. You can just, type whatever you feel like. And this is not actually, there's actually multiple standard IQN formats. So this is like the most common one that seems to be used by default. But I think in the RFC there's like multiple ones that are considered like officially valid or officially correct. So yeah, when I created IQN, I just created this one by default. This name is really kind of too long. So maybe if I was doing this again, I would type something shorter. And then it also created the portal group, and then created the default portal. So you can see basically with this configuration, under this, if under iSCSI, then there's the target, which is IQN, and then there's this TPG one, that's the target portal group. And then under portals, you can see that there's this 000 colon 3260. And so that is the port, the IP and port that this iSCSI target is going to listen on, basically. And so that's what is created by default. And so, well, in a lot of cases, you don't want that. You might have some dedicated NICs that's going to be used for your storage traffic. So that's why on the next step, I went ahead and delete that one, this 000, delete 000 and the port, and then I create a new one on the IP address of this machine that I want to use. So now when this iSCSI target's started, then it's only going to listen on that one IP that I want it to. And you can do it on multiple IPs, or you can use the default one if that's going to work for you. It's really up to you. Okay, so next, after you've created those previous things, you need to basically add some initiators that's going to have access to this target. And so you can see here I'm adding basically some Red Hat, well, I guess in my example I'm using some Fedora, adding the IQNs from some Fedora machines, and these are just the default IQNs that's there. That's like when you install Fedora, if you install the iSCSI initiator, then it's going to create an IQN by default here. So it's just like IQN.1994-05.com, the Red Hat, colon, and then some random stuff. The IQNs, they need to be unique. So I think that when you install a package, it will randomly generate that last section of the IQN. All right. And again, you can see, like, before doing this configuration, I'm just navigating to that part of the configuration. So, the IQNs or the IQNs of the initiators need to be added under the ACLs section of the portal group, right? So then I just did, CD iSCSI and then the target IQN and then /TPG1/ACLs. And there's tab completion, so it's really, you don't have to type that all out. You can just press tab. And if you're not sure what's there, you can just press tab twice, and then it will tell you what you can type, give you the different options. So it really makes it very, very fast and easy to configure this thing. Okay, and then the next step, actually basically like the final step, well, almost the final step, I guess, would be creating the LUN. So previously we had added this backstore or this block device that I want to use. Well, those backstores in the configuration exist kind of separately from the targets. So when you actually want to use one of those backstores with a target, then you create this LUN. That's what kind of ties it together in the configuration. So then you would just navigate to the LUNs section of this portal group for this target, and then simply type, create space and then the name of the backstore, which is, backstores/block/BS0, and press enter. And then it creates a LUN, and then it will map the LUN to all of those IQNs that you had already added. So it's, pretty easy. So any questions so far? Like anything not clear? Okay. So then basically you are almost done at this point. And so the next step is to configure authentication. So with iSCSI you can, I guess you would be able to configure authentication if you wanted to, right? If your storage network has a lot of servers or something, then you might want to configure authentication because, like if, every server can access every LUN on every target, you might accidentally, connect to the wrong target and wipe out somebody's data. It's, not that good. So, this authentication is configured on the portal group level, and so it's kind of, a little bit tricky because it doesn't show here, like on the previous slide in the configuration, there's no like authentication showing. So this is where like the tab completion comes into handy. You can just press tab and a couple of times and it will show you what's available. And so, basically at the portal group level, there's these things called attributes, and there's a few attributes, and one of them is authentication. So you could, if you wanted to use authentication, you could just, set a username and password basically. And the kind of the interesting thing, at least on Fedora, when you're configuring this, the authentication is enabled by default, but with no username and password. So it's kind of weird. Like you can't actually use it basically. So they're kind of either forcing you to either set a username and password or just disable authentication entirely. So for this demo, I just disable it. Just set attribute authentication equals 0. And if you wanted to create a username, it will be some kind of similar command, like set username or something like that. And so at that point, your configuration is actually done. So then the last step would be to save the configuration. And so actually, by default, at least on Fedora, you can just exit and it will save the configuration. But if you want to like just be double, careful, I guess, and make sure that your configuration doesn't get, erased or something, then you can just explicitly type save config, and it will save the configuration and then apply it. So it's really just really, pretty fast. You can see those 5 steps. I mean, it's pretty straightforward. You just adding the disk, creating the portal group, which is created automatically, and then adding the, configuring any IP addresses you want on it, and then, adding the LUN, basically. It's just like 5 steps. And then, of course, you have to check that it actually kind of works, right? So then I exit the command, and that's when I just check, what I like to use. I like to use just netstat to see, oh, well, if there's something listening on this iSCSI port, right? That's kind of just like one of the most basic checks, right? So then, well, there it is. There's this 3260 is listening, and there's no process listed because it's just the kernel. Again, it's kind of a little bit different than some other iSCSI initiators. There's actually a process that's handling it. So when you would type this command, you would see this port 3260, and then there would be some kind of iSCSI related process there. But yeah, with Linux I/O, it's all the backend stuff is in the kernel, and so there's not like a process there. And certainly it's different than something like something like Samba or like Apache web server. There would be port 80, and then there would be a process there. There's no process. Well, the process is in the kernel. So next would be, now that Linux I/O is configured, then you can go ahead and configure the initiators, right, to actually connect to it. And that's going to vary by the OS of the initiator. So with Linux, we have this command called the iSCSI ADM, and it's actually you might want to check the man page. I don't know. It's a little bit tricky, I think. I feel it's a little bit tricky, but because there's a lot of different switches and stuff, and you have to do things in the right order to make it all work. But first of all, on this is actually like a real client. I had all these slides are real. I created them from screenshots from like a real demo environment. So you can see you can actually match up this IQN here of this machine to the one that I had added to the Linux I/O iSCSI target. And actually you can kind of see like on the screenshot there's different tabs. So like the the Linux I/O box is the .41 server, and then this initiator is .56. So this is not like typing all this out or something. This is like something I actually did and actually worked. So first I checked the initiator, and it matched what I had put into Linux I/O, and then you can use the iSCSI ADM command to first you can list what targets are accessible to this initiator, right? So with that it's iSCSI-ADM-M discovery. -M is the mode, so discovery mode, and then -T is send targets. T is the type of discovery, so it's send targets, which is like, I guess, telling the target to send me what's available, I guess. And then -P, which is I guess probably the portal or the IP address of the target I want to use, right? So that's the .41 I had in my lab here. And then the response, it lists out this let's say the IP address and port, and then the IQN of the target I want to use, right? And so the next command, I actually want to access one of these disks in this iSCSI target. So it's a pretty similar command. It's just iSCSI ADM, and then -M is node mode. You can check the man page if you want to know like why it's node mode, but then -T, capital T, which is the target or the IQN, and then -L is kind of the important one, which is login, and then -P is IP address. So then you can see here telling me it's logging in to the target basically, and so then it says it's successful. So then well, how would you check this really successful? Well, kind of one easy way is, well, is the disk there? Did the disk get added to the server? So then I just use fdisk to check out this disk, and well, the disk was there, and that's that 8 gigabyte disk I had added earlier, and it seems to have worked. And if there's any kind of problems, or if you want to have check any more details, then you can just check the logs, like the var log messages, or I think like on Fedora now it's a command journal CTL, and you can actually check out the logs of this iSCSI initiator. And then when I'm done with the disk, then I want to log out basically, and that's actually exactly the same command as the login command, except for instead of -L, it's -U. And then it's successfully logged out, and then I didn't show my screenshot, but the disk, that dev SDA, got removed. And here's another one. If you're familiar with vSphere, this is kind of how it looks, using the GUI to add this iSCSI target. Just go to the configuration, and then go to like storage adapters, and then you'd have to, if you're not using iSCSI already, you have to add the iSCSI software adapter. There's just a button to do that, and then you like go to I think the properties of that iSCSI adapter, and then you can add this target essentially. And then once you add the target, then you would go back to the I think the storage tab, and then you can add a LUN, and then it will show up there if everything's working. And actually, it does actually work with this configuration. You can see on the bottom there is the target, one of the targets I have in the lab.
I have a question.
Yeah, sure.
So, earlier in the demo, when you created the IQNs, you created 2 IQNs.
Right. Yeah.
But here you're only specifying 1. Why 2 previously and now?
Right. So those ones that I had specified earlier on that slide was adding the IQNs of the clients or the initiators. So I added 2 clients.
Oh, okay.
Yeah.
The IQNs per client.
Well, yeah. So let me go back to the configuration. So there's two IQNs. The IQNs apply to both the servers and the clients, right? So in this configuration here, when I create the target or the server, it's this IQN here. This is the IQN of the server.
Right.
And then I want to add, it's pretty useless by itself, so I want to have some clients or initiators connecting to it. So then that's when I add the IQNs of these 2 initiators. So these 2 IQNs are 2 different Fedora boxes, and they are going to have access to this other Fedora target, basically.
Just not at the same time.
Yes, you could, you would have it. You could have them, have it accessible at the same time. You would obviously need some kind of
Shared file system or something?
clustering file system or something like that.
Okay.
You know, just in this slide, I just showed that you can add multiple, in the slides deck overall, I'm only using one of these IQNs of the clients, but, you can have as many as you want.
Thank you.
Yeah, sure. And so actually, like in this one,